I am Brad Keelor. He is Tom O'Rourke. Next up on Director's Cut, find out what mail he maybe should have opened a little quicker that he got from the National Academy of Engineering, but everything worked out in the end. Hello again, everybody, and welcome to another episode of Director's Cut. My name is Brad Keelor. I'm the director of the Geo-Institute, and that is why we call this show Director's Cut. Every single week, I sit down with a different GI member who has a trove of stories to tell us about themselves. Some of them are personal, some are professional, but every single last one of them is fun. If you don't know anything about the Geo-Institute, we have about 12,000 members. We're part of the American Society of Civil Engineers. Most, if not all, of those 12,000 members are geotechnical engineers and or geologists. If you like what you see today, and I think you will, I predict that you will, you should click subscribe, you should click get notifications, and we will tell you every time we post something new to the YouTube channel. With all that out of the way, our guest this week, coming to us from Ithaca, New York, or close by there, Professor Emeritus of Civil and Environmental Engineering from Cornell University. It is Tom O'Rourke, Geo legend Tom O'Rourke. Thanks for doing this, Tom.
My pleasure. Nice to be here.
We are going to have a great time today. Again, I am convinced of this. We've got 10 questions. 2 of them are the same as we do in every interview, and we begin with one of those. Describe your job in 45 seconds.
Okay. Well, my job is to teach people and to create new knowledge. So what I've done is all my career, I've taught people with respect to classes in geotechnical and related areas of civil engineering. And I've created new knowledge with respect to doing research. Current areas of research focuses on the way that pipelines behave when they're subjected to permanent ground deformation. We have a large-scale laboratory that does that. And then on the basis of having this new knowledge, we're able to integrate it into classes, and we're able to integrate it into talks that are given at various locations. To talk about how to engineer for some of these complex systems and to design them with respect to extreme events.
And we are going to hear more about that as we progress through the interview, of course. Director's Cut is also about these nostalgia questions. We make you think way back. And in this case, I haven't asked anybody this question yet, so we're making you think way, way, way back. What is your earliest memory, the very first one?
Probably the earliest memory was a Christmas tree. So I don't know how old I was. Maybe I was 1 or 2, somewhere between those ages. And I came out and I saw this Christmas tree in our house in Philadelphia at the time. And my parents said, all I could say was, oh boy, oh boy, oh boy. And I hardly said anything up until that point. And that sort of was the beginning of my talking part of my life. And what I remember with respect to the first memory, this Christmas tree all lit up with these little bubbles going on and so forth. It was a real 1950s type, early 50s type Christmas tree.
Now, I don't know if this plays into it at all or not. Was your family, I know at the time, one of the things that was pretty common is that people would put the tree up on Christmas Eve and the kids didn't see it until the next day. Do you know whether this was that kind of situation or whether it was up a little bit more in advance? Or
no, so that experience of having the Christmas tree the night of Christmas is actually still followed by European countries. So there's some people I know in Austria that put their tree up on Christmas Eve. Our tree must have been set up like 2 weeks or so before Christmas. And we had a heritage where we would take the tree down at the time when the wise men came. So I think it was January 6th.
January 6th. Definitely. Our strategy now, and of course with artificial trees, you can do whatever you want, is to leave it up as long as possible. We're sometimes the week before Thanksgiving kind of family, and I don't think there's anything wrong with that. We have to get in. I mentioned we would talk a little bit more about the research, specifically about the Lifelines research, and you've got a fascinating story about how you started getting into this, and it involves the great city of Washington, D.C. So if you recount that a little bit for the viewers, that would be great. How'd you get into Lifelines research?
Okay, so the entree into Lifelines research was really with respect to research related to deep excavations. At the time, I was a part of a group from the University of Illinois that was investigating the performance of either tunnels or excavations on the Washington, D.C. metro. My particular project was the excavation for the Gallery Place station. So if you go to Washington now, you get out at the National Portrait Gallery. I did the research with inclinometers and multiple position extensometers and finite element analysis and so forth of the deep excavations that eventually became Gallery Place Station. And during the investigation of that project, one of the questions was, well, what's happening to the pipelines? We were supposed to be looking at the National Portrait Gallery, which we did in great detail. But I also put some lines together and some points together and some settlement measurements on pipelines. So that became a kind of a secondary issue of the effect of tunneling or excavations on infrastructure. Primarily, people were concerned at the time with buildings, but they also became increasingly more aware of the influence on the pipelines, which generally occur. They're closer to the actual excavation movements than the buildings. And so they become pretty important in terms of designing for things. When I came to Cornell, there was a National Science Foundation research program that said, for earthquakes, please submit your ideas and we'll make a selection in terms of who is worthy to go forward to get this National Science Foundation grant. And so I submitted with respect to pipelines and earthquake motions. And so that was successful. I ended up with a couple of research projects related to pipelines and the effects of earthquake motions, either being at lateral spreading from liquefaction or differential settlement, or landslides or surface rupture effects, fault rupture effects. And then eventually started looking at the performance of lifelines as systems. So if you have water, you have electrical, or you have gas and liquid fuels, they're generally parts of larger systems that have pump stations, redundant pipelines, reservoirs, and so on and so forth. And we ended up working for a lot of utility companies, among which was Los Angeles Department of Water and Power. And we eventually developed a computer program for Los Angeles Department of Water and Power that modeled all 10,000 kilometers of their pipelines, their reservoirs. And by reservoirs, sometimes we think of big reservoirs. They have a lot of tanks that they call reservoirs. So maybe 300 of them through the system, and all sorts of valves and special features. And we used this model to develop policy for LADWP, which they use to this day. In case there's an earthquake effect, they know what they're going to do based on some of the research that we perform for them. That evolved in terms of system performance to helping develop the next generation of hazard resilience lifelines. So what we do is we kind of fight fire with fire. During earthquakes, you get a lot of large ground deformation, and pipelines respond to large ground deformations by generally breaking. But we're talking about dealing with water supply pipelines that have special joints that will either expand or contract. So axially, they absorb the movement. Differentially, in terms of movements perpendicular to the pipelines, they absorb the movement by rotation. This could be new materials such as polyvinyl chloride and a special PVCO, which is oriented polyvinyl chloride, and special kinds of steel and so forth. So we helped develop at our large-scale testing facility, and anybody can Google it. They just put Cornell Lifelines and they'll get there. We helped develop 10 new systems that never had been in place before that accommodate large ground deformation because the pipelines become shapeshifters. They're able to adjust in terms of geometry and accommodate this large ground deformation, and they're a real step forward. And then finally, this has evolved, the systems aspect of looking at the water supplies or electric power and so forth has evolved into infrastructure, so spatially distributed infrastructure. And we're currently going to have a big workshop with the United Kingdom, 25 representatives from the US, 25 from the United Kingdom, sponsored by the National Science Foundation, sponsored by EPSRC on the British side. And that's going to be looking at the funding and financing of infrastructure together with some emerging technologies which tend to bring funding and investment into infrastructure, and is an alternate way of building infrastructure, which we sorely need and sorely need, because we just don't have the money. We don't have the liquidity unless we go to private markets.
That was great. Thank you for walking us through that. I have two follow-up questions, and they both go back to DC, so I apologize. The first one is project related, sort of, and the second one is not at all. Some deep tunnels that were dug for Metro. Gallery Place, I am actually not sure of the depth, but did you guys have any issues with one of the big problems we have in the DC area with underground construction is dark fiber or black fiber, all these telecommunications technologies that the secret agencies have. Was that an issue for you guys when you were working on that?
Well, I was working on these excavations, and there was on the 7th Street side of the National Portrait Gallery a tunnel that went up there, and it was right at the interface between the Cretaceous clays and the overlying sands and gravels from the Pleistocene deposits. So you had a boundary that was a contrast in permeability of maybe 5 orders of magnitude. And you couldn't deal with the water on that interface, right? It's particularly given the technology at the time. So as the tunnel went up 7th Street, this water poured in along this interface. This was before we had pressurized tunnels and so forth. So they were trying to stop the groundwater flow and the collapsing soils. And they weren't really able to, and you ended up getting settlements, centerline settlements in these tunnels on 7th Street in front of the Fine Arts Gallery on the order of 6 to 12 inches. Centerline settlements is nearly a foot. And they had some significant effects on the buildings on 7th Street. So that was really a very important part of it. So the movements that they generated at this particular location broke a couple of water pipelines. You often think of a 6-inch water pipeline as not being very important until you break one. Yeah. And then it's like an underground river is let loose before they can get to the gate valves and turn it off. And tremendous amount of water comes out. It's a source of erosion, of additional lifeline undermining and problems, because now you're flooding the area. So it's quite significant. And they did take out a cable. They took out a telecommunication cable that was really important. We find this in a lot of streets. They're often secret. They don't want people to know where they are, and therefore they rarely say anything about them. But when they go, you can have all these trades on the stock market going through these cables, and all of a sudden it's interrupted. It's gone. This has happened in New York a couple of times with construction that goes on. They break a cable, and it's a tremendous problem. There is interdependency that occurs when you do deep excavations or you do construction, and the possibility of distorting or breaking one of these cables becomes really quite significant. It has a tremendous influence on the building continuity plans for a city.
The other follow-up there, if anybody knows anything about Washington, D.C. in the 70s and 80s, there were a lot of not super great neighborhoods. And the area around the Portrait Gallery and Gallery Place is fantastic now. It's beautiful. Did you have any wild stories going into work every day while you were there?
Well, that's really interesting. You're absolutely correct. You really couldn't go to my site without meeting somebody after dark. It was a very dangerous place. I think when I was in Washington, D.C., it was 73 to 75, something like that. And you really, nowadays, since you have the metro stations there, that whole area is a wonderfully invested area, much different than it was back when they were building the thing. Actually, when you were building the deep excavations next to the National Portrait Gallery, obviously the excavation got deeper and deeper. And the two excavations that I was involved in, one was 60 feet deep and the other was like 72 feet deep. So they were fairly deep cuts. And at one time, I fell off the ladder and I came down about 20 feet and hit a steel girder. So these steel girders have these big flanges on them, and I hit the corner of the flange. But fortunately, I had my field book in my pocket, and that took the load and distributed it over me. They ended up taking me out of the excavation on an ambulance on a stretcher. There was a big crane that came over and took me out. And I went to the local hospital, and I still remember going to the hospital. And I went in there, and the guy was monitoring me, and he says, he turns around and he gives me a glass of orange juice, and he said, "Would you please drink this?" So I drank it, and I said, "What's the matter?" He goes, "In about 15 minutes, you're going to be near passing out, and this sugar will help you in this whole process." And I didn't believe him. 15 seconds, later, I was just about passed out because you had a delayed reaction to the shock to the system.
That is amazing. Fabulous stories. That's really good. So we're going to go back into some nostalgia here as we move on throughout the interview, and back to your childhood again. How did you spend most of your free time as a kid? Was there any one or two things that got most of your attention?
Well, as a child, we used to have a grade school behind our house. And so I was always able to go over to these fields in this school yard. And in the actual fields, I used to capture bees and butterflies and so forth, and really spent a lot of time in nature, capturing these various things, taking a look at them, and just wandering around this field a lot with some friends and sometimes alone. So that's what I remember quite vividly about spending a lot of time during my childhood.
Exploration. Fantastic. This next question is the one we teased during the top of the interview. This is an amazing story, and I'm glad I got a sneak preview of this. What has been your biggest "I can't believe this is happening to me" moment in your career?
Well, I think it was in 1993. I got a package from the National Academy of Engineering, and it came. I was really busy this particular day, so I took this package and I just put it on the side, and I managed to finish up whatever was happening. And then I went over and I opened this package, and I had been elected to the National Academy of Engineering, and I had no idea that this was going to occur. It was a big surprise at the time. And I had let this sort of package stay there for the better part of a day on the side of my office. And I actually didn't believe it. I actually called them directly to confirm all of this activity. And that's really one of the big "I can't believe this is happening" stories, because it was such a surprise. And I didn't respond very quickly. But then when I became aware that it was real and this wasn't, people weren't kidding, I then just went into action and started communicating with people.
I like to ask this one to people who have been inducted into the NAE. Have you ever sat down and looked at the list of names that yours is mixed in with?
Oh, sure.
What's your reaction to that? I mean, it's got to be a little, I don't even know what the word would be. Surreal, I guess, maybe.
It's pretty amazing. There's a lot of people that are members of the National Academy. And there's a lot of people who founded the National Academy of Engineering. People like Nate Newmark, for example, was in the inaugural class of NAE. And Newmark is legendary in terms of civil engineering. I knew Newmark personally. I went to the University of Illinois when he was the department chair, and was on the faculty student council, and managed to have a number of private conversations with him. But he's one of these brilliant people that had the Newmark charts, that did this earthquake design in Mexico City, these buildings that stood up during earthquakes, and nobody had ever really figured this stuff out. He was a real pioneer, and there's a number of people like Nate Newmark in the National Academy or founding of the National Academy, and they're really just awesome in terms of seeing what they accomplished in their life.
That's great. And I also I have to tell everybody that when we talked about this yesterday, you said you were very young when you got inducted into the National Academy of Engineering, and you were 43, which is very young for the NAE, but I liked that because I am 42, and most people do not describe me as very young. So that warmed my heart yesterday. The other question that we ask everybody that comes on Director's Cut is, how did you first get involved in ASCE and then later on GI?
Okay, so ASCE was really one of my first major professional society involvements. When I went to Cornell University as a professor, they were looking for people to sit on the executive committee for the Ithaca section of ASCE. And of course, this sounded like a good idea to me. So I went through all the positions on the executive committee, and then I became the president of ASCE Ithaca section from, I believe it was 1982 to 1983. I was also the faculty advisor to the student chapter of ASCE. And while I was faculty advisor, the students built this very large pavilion for summer camp in one of the the New York State parks, which are really beautiful. They're really big waterfalls up here, and they're really nice. So I almost call them national parks because they're almost like national parks, but they're maybe not quite like them, but just slightly a cut below. So we built this big pavilion. It was a winged structure. It was actually kind of complicated. And then the next year, the students built a 180-foot suspension bridge across Fall Creek. And they won the Ridgway Award for that, which is not that easy to get. The Ridgway Award is given by ASCE to the best student chapter, and lots of student chapters are building and doing amazing kinds of things. So we were really proud of the students. They did a great job. They left these two things as part of a legacy of community giving and feedback. And I remember that the structures are now about 40 years old, and they're still functioning. So what's really amazing about civil engineering is the ability to build something that improves the community and have it go on for year after year after year. And we finally come to the point in time with the suspension bridge that we're going to have to renovate it with respect to the decking and the handrails. The cables are still doing really well, and so's the reaction blocks and so forth. But that's a project for the current ASCE student chapter. So they're actually designing and building this refurbishment, which is going to go in. And it's like one generation is talking to another. It's really nice to see this sort of thing happening. With the GI, it was I was before you created the GI, right? So I got involved in the GI as part of my involvement with ASCE. And I think there was an involvement with the GI that was very close to when I was a technical chairman for the excavation committee, the earth retaining structures and excavation group. So I became involved with the GI, was able to give the Terzaghi lecture and so forth. So it's been a wonderful, for me, arrangement with the American Society of Civil Engineers and with the Geo-Institute.
All you have to do is check that box on your renewal form and you become a GI member. But it's so much more than that. And we're thrilled to have had you all these years. You've had some great overseas living experiences, I think both professionally and personally. You want to talk briefly about living in, I think in the UK, to me, that's the most interesting one, but you also had the opportunity to live in New Zealand also. And yeah. I want to hear a little bit about the rugby career here too. That's got to play into this.
So in the 1970s, there was a research program supported by the Department of Transportation with respect to their Urban Mass Transportation Administration, UMTA. And this was when I had gone to the University of Illinois. They came up with this research program and they said, we will sponsor you if you are willing to go to the United Kingdom and work there at the Transport and Road Research Laboratory. So I got it all cleared with the people who were running the department in Illinois. And I went and I lived in the United Kingdom for about almost 2 years. And I was working with the Transport and Road Research Laboratory, and I was working there on a whole variety of different tunnels throughout the United Kingdom. I lived in a place called St. Margaret's, which was halfway between Richmond and halfway between Twickenham. And when you first go to the United Kingdom, people meet you and they greet you and so forth, but the British are a little reserved, so it's difficult to make real close friends unless you've been there for years. And so I was kind of starved for friendship in St. Margaret's. I should have lived down in Crowthorne, where the Transport and Road Research Laboratory was, in which case I would have been fine socially. But I ended up becoming good friends with my postman, who was a Scots person, and he took me to a place in Twickenham where he would go as his local, have a few beers, and I go with him. And then he said, you ought to go out for the rugby club. So I went out for the local rugby club, which was called Old Orleans. And it turns out that they were a pretty good rugby club. They always made the Middlesex Cup match. They never won it, but they were always in the semifinals or the finals of the Cup match. So I went from the 5th team in the rugby club to the 1st team and actually played some groups like the Barbarians and the Saracens and so forth. I mean, people, that Harlequins, excuse me, semi-professional teams, some really good standard of rugby. And after I had this experience in the United Kingdom, we ended up living in New Zealand for a number of years. And New Zealand is a great rugby country. And so they were very taken by the fact that I'd played all this rugby and was able to relate to them of all this that had happened during the rugby time.
That's great. Fantastic story. And we should put together a GI rugby side. And then I'm willing to bet you'd still be one of our top players. So you mentioned in one of your early answers that you gave the Terzaghi lecture, and that was the first Terzaghi lecture after I started at ASCE, actually. It was in 2016. You've also had the honor, had the privilege of giving the Rankine lecture. And in that, you mentioned a couple of your mentors, David Henkel and Mel Esrig. And I was wondering if there's anything surprising you wanted to share about either of those guys.
Well, they're both terrific people. I got to know them at Cornell. My selection in engineering was sort of, I made up my mind about what I didn't want to do. And so originally I was going to become a mechanical engineer, and I decided I didn't want to do that. I really liked some of the older people that I knew at Cornell who were in civil engineering. So I kind of became civil engineering oriented. Within civil engineering, I really didn't know whether I wanted to be in hydrology or I wanted to be in structures or I wanted to be in geotech. But it was really these professors, David Henkel and Melvin Esrig, who were professors at the time of geotechnical engineering at Cornell, who were just terrific role models. Dave was a British person. He had come to Cornell, I believe, from India. And he was at Cornell for about the better part of a decade. And he was a great person to inspire you. He did a lot of work on landslides. He is actually one of the first people to evaluate the effects of big waves during hurricanes and their effect on slope stability in the underlying soils of the Gulf. And to this day, the designs that go on for these pipeline systems and these offshore oil rigs, gas rigs, rely on a lot of the work that he pioneered. And so he moved back to the United Kingdom. He was on the board, executive board of Arup Partners, and just had a great career. He also gave a Rankine lecture. During the Rankine lecture, I showed his image. He had passed away at the time. And Mel Esrig was still alive. And another person, he did electrokinetics. He was one of the very first people with Woodward Clyde, an old geotechnical company, which has been absorbed by many other companies since that point. he did a lot of work on geo-environmental engineering, and we used to have him come, and he would give classes to my class on geo-environmental types of issues when it was just a fledgling study area. And one thing that always impressed me by these people is they just loved to teach, and they really had a great respect for students. And they were just wonderful for people to learn from. And it was really because of them that I chose geotechnical engineering. I always like to say that I didn't choose geotechnical engineering so much for the technology as for the people.
That's fantastic. I thought you were going to finish that with "it chose you," but which is another good way to get involved. But that's great, and I'm sure you have inspired many people throughout the years to become geotechnical engineers as well. So it all comes full circle. But one thing I really wanted to ask you, you've been involved in a number of media endeavors throughout the years, whether it was a TV show, radio show, podcast, whatever. And in many of them, it was public outreach on civil engineering. I know there was a PBS one about 20 years ago, and this is where I came up with this question that you were involved in, and there was a profile of you on this PBS Kids website. Why do you think this kind of public outreach is important?
Well, I think it's extremely valuable for people to articulate what they do. And this is especially true in the engineering profession. Engineers frequently develop a reputation for being doers, but they don't ask a lot of questions and they don't necessarily explain a lot what they do. They get very much involved. They solve a particular problem. They come up with a design. They come up with a bit of construction, and they wait for the next problem. But what they do has a tremendous impact on the national community, both nationally, internationally, local, and broader speaking. And the support that engineering gets, at least in this country, comes from having a public profile. So if you have this profile, if you're able to articulate what you do, if part of what you do is focused on national and international outreach, so that you explain what you do either by radio interviews or by podcasts nowadays or by television spots, that really helps as much as anything. I think probably more than anything, to get people to understand what you're doing and to see the value of what it is, so that they end up supporting it because they know something about it. They realize the value. They see that it's possible to do these things, and these activities need their support. So I'm a great believer in public outreach.
And we appreciate it. It needs all the help we can get, and to have our members out there doing that work is fantastic. A couple of days ago, when this airs, people will have celebrated Easter. One of the things they probably did is consume large amounts of chocolate and other candy. I got to ask you, what's your all-time favorite Easter candy?
Well, I kind of like chocolate bunnies, right? And that probably comes from the United Kingdom experience. You know, my wife is from the United Kingdom, and the British really celebrate Easter, more so than what would happen in the United States. And I always think of the chocolate Cadbury bunnies at Easter time because they taste so good, and they're part of the whole cultural aspect in the United Kingdom of recognizing this holiday.
Great answer. You can't go wrong with Cadbury chocolate, especially in bunny form. I think we have to ask you one bonus question. Here we are at the end of the interview. In doing the research for this, I found out that your daughter is a police officer in Washington State and is a little bit of a YouTube star because of that. Any comments on your daughter's career as a police officer and how she became a YouTube star?
Well, she graduated from Cornell, and somewhat unlike her classmates, she decided to pursue her career in being a police officer, and that's somewhat unusual. So she went to the Seattle area. She's a police officer in one of the Seattle area police departments, and when you first join a police department, you're on patrol. So you have all these crazy hours at night and going in pretty unusual places and seeing things. And she's worked her way up. She went to police academy. We went out there for her graduation. She was actually the president of her class at the police academy. So there was this 26-year-old young woman bossing around all of these Rangers and Navy SEALs because the police department will favor ex-military folks. And there she was having a march up and down and so on and so forth. She since has won the Distinguished Service Award from them. And she has a perspective on policing, which I think is great. Her focus is to be a resource for the community. So they're all about preventing bad actions before they occur, not locking people up, but preventing them by having a strong outreach program for the community. And I think her career on YouTube, it probably stems from that. She's a very good communicator. I know she's on the singing group that goes around when police officers die, or unfortunately they die in service. And she will sing the national anthem at their funerals, as well as the Canadian national anthem. I didn't realize until she joined the police force near Seattle that they have a very close program with Canadian police officers and the Mounties, actually. So she actually sings the national anthems of both countries. We saw this on YouTube one time, and she sings without accompaniment, which is hard to believe. So there was this funeral of about 1,000 people, and she got up and sang both of these national anthems. It was really quite impressive to see.
That is fantastic. We will put one of the videos that I found on YouTube down in the show notes under this. And it is hilarious. It was great outreach. And she does have a great voice. You are dead on with that. And you guys have to be incredibly proud of her because it looks like she's doing an amazing job. Tom, you survived all the questions, made it through Director's Cut. I always say that everybody makes it through, but it's still an accomplishment. You did a great job. For all of our viewers out there, again, if you liked what you saw and you're here at the end, so you probably did, click subscribe, click get notifications. We'll let you know every time we post something to the channel, which is super frequently. So Tom, thanks again for doing this.
My pleasure. It's been a great honor to be on this program, and it's been wonderful to talk with you about it. Thanks.
I had a great time too. We will see everybody with a brand new episode of Director's Cut next week.